Assalamu alaikum everyone. Welcome to another video of chemistry with Sarip Sambe. In this video, we are going to talk about the concept of relative atomic mass, which is also denoted as A subscript R. Relative atomic mass is the average mass, of the isotopes of the element an element compared to 1/12 of the mass of carbon 12. Basically, carbon 12 is my comparison, and compared to carbon 12, I'm calculating the average mass of the isotopes of an element. So we will take all the isotopes of the element, we're going to take the average of their masses, and we're going to get the relative atomic mass. So this is a definition of relative atomic mass, and keep in mind that this definition is very important from exam perspective. It shows up a lot in the exams. How do we calculate the relative atomic mass? So there's a very basic and simple formula. If you want to calculate the relative atomic mass of any element, you have to take the mass of the first isotope and you multiply that mass of the first isotope multiplied by the percentage of the first isotope plus you take mass of the second isotope multiplied by the percentage of the second isotope, and then so on and so forth. So if there is a third isotope, you're going to add a third isotope, so on and so forth. So dot dot. So you will continue that. So dot dot. Right? I'll just move it a bit. Yeah. So plus dot dot dot. Divided by, because since it's an average, you divide this by the total percentage, which is obviously 100. This is the formula. So let's look at one of the previous examples. If we talk about boron 10 and 11, so we will say that boron 10, and we don't know the percentages of these, so we will have to be given the percentages. So let's take an example. Question number 1. This is some element and they have given me the mass of one isotope and the mass of the second isotope, the percentage of the first isotope and the percentage of the second isotope. So using this data, I can find out the relative atomic mass of this element, and then I can also find out the identity of this element. So I would put these values in the formula. So relative atomic mass, AR, is equals to mass of the first isotope 6.015 multiplied by 7.5 plus 7.016 multiplied by 92.5 divided by 100, because the total percentage is 100. So I'm going to divide this by 100. So I'll get the formula. So let me just quickly calculate this for you. Okay. So my relative atomic mass is coming out to be 6.94. 6.94. Now I have to see, I will go to the periodic table and I will see that which element in the periodic table has a mass of 6.94. So when I look at the periodic table, I will get the identity of element X. So I'm going to compare the AR 6.94 with the element that will have the identity. So since this is 6.94, I will look at the periodic table. Let me look at the periodic table. Let me look it for you. New window. And since they're saying the atomic number of element X, so this is used to medically treat some mental disorder. So this is interesting, right? So I'm going to quickly look at the periodic table. 6.94, which is almost close to 7, and that would be lithium. The mass is lithium. So this X would be lithium. X is lithium because 6.94 is approximately 7 and lithium has a mass of 7. So it's lithium, Li. Let's do question number 2. Boron has 2 naturally occurring isotopes. I told you boron. Now here they have given me the abundances. So let's find out the AR of boron. It's going to be 10. So mass. Okay, so since they have given me the actual mass, I'm going to use this mass. This 10.013. This is the actual mass. This 10 is the rounded off value. This 10.013 is the actual mass. I'm going to use the actual mass. So 10.013 times the percentage 19.8 plus 11.009 times 80.2% divided by 100. So when I solve this, I will get the value 10.013 times 19.8 plus 11.009 times 80.2 divided by 100. So this is giving me 10.8. So the relative atomic mass of boron is 10.8. Helium has 2 naturally occurring isotopes, helium 3 and 4. The atomic mass of helium is 3.895. Which isotope is more abundant in nature? Explain. So this is a difficult question because they haven't given you the percentages, but it's telling you that it has only 2 isotopes. Helium just has 2 isotopes. So helium is 3 and 4. So AR, they have given you the relative atomic mass value, so you don't need to calculate that. The AR value is already given. They've given you the mass of the first isotope of helium, and we are going to assume the abundance is X, the percentage is X for the first isotope. Plus, if the first isotope is X, then the next isotope would be 100 minus X, because obviously the total abundance is 100 divided by 100. So I can just find out that which of the isotope 3 or 4 is more abundant. So I'm just going to take 3.895 times 100. And then this is giving me 389.5. So I'm going to solve in bits so that you can easily understand. Plus 400 minus 400x. So this is going to be 400 minus 389.5. This is 10.5, and then on that side you're gonna say this is going to be 400 minus 3x, so that's going to be divided by 400 minus 3. So when you solve for this, you will get the value of x. So 400 minus 389.5 is 10.5. I'm just going to write below 10.5 is equals to, and I will take the 400x and 3x to the opposite side. So that's going to be 400 minus 3, 397x. So when I do this, wait, sorry, my bad. This is 4x, not 400x. Okay, sorry. Yeah, so this is going to be 3x minus 4x. So 3x minus 4 is x, so x is equals to 10.5%. So if x is 10.5, which means the 1 is 10.5, then 100 minus 10.5, 100 minus 10.5 is 89.5. So this is 89.5. That means the abundant isotope of helium is 4. Helium 4 is more abundant. Because helium 4 is getting a percentage of 89.5. Helium 3 is only 10.5%, as I've calculated from the calculation. Now question number 4 is fairly easy, and you can solve it on your own and find out the answer for question number 4. So this is how you work out the relative atomic mass of each element by putting the values in this formula. Keep in mind that these relative atomic mass values are given in the periodic table. These values you see over here, 51, 52, 31, 11, these values are the values of the relative atomic mass of each element. And how have they been calculated? By taking the average of the mass of each isotope of one particular element. So I hope you understood the concept of relative atomic mass and how to calculate it. In the next video, we're going to see what ions are, how many sorts of ions are there, and how to write their electronic configurations. So until then, stay tuned. Thank you, everyone.